Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question extracted from 2018 time zone 1. So that's question number 6. This is going to be an easy question but cross topics, crossing the topics of both the topic 4, bonding and structure, and also topic 3, periodicity, in terms of asking for the acidic and basic behavior of some of the oxides, right? So here that they say, which describes the oxides of sodium correctly. So given the choices with combination in terms of the bonding nature, the conduction, or you can say the conductivity of electricity, if they're in pure state, that means no impurities, right? And finally, the topic 3 substance, right? pH of the aqueous solution. So first point, students at the very first beginning must be able to know that oxides of sodium is what we call a metallic oxide, right? Metallic oxide. So remember, metallic oxide combines both the metal part, sodium, and the non-metal parts, right? So when metals and non-metals meet together, as always, that they will form an ionic bond. Of course, the reason behind is not because this is going to be always true for metals and non-metals, but the fact is metals always having a relatively low electronegativity, while non-metal is always having a high electronegativity. So that means here, the difference of the electronegativity is going to be large. When the difference of electronegativity is going to be large, this is going to be an ionic character. If not, that will be a covalent character. Obviously, the details will be further discussed in our chapter 4, right? So that's why we can confirm that when metals and non-metals form bond together, that is normally an ionic pattern. So the first point, so that's why not A, not B. Next point, so for ionic compounds, what is the situation when they can conduct electricity? So remember, when thinking of conductivity, as discussed in the topic 4 concept, we always think of two things. Either we have the mobile ions or the localized electrons, right? Either one of them existing, then that substance will be conducting electricity. So obviously, in the case of ionic compounds, we are looking for mobile ions particularly, right? In terms of mobile ions to be existing, the condition is that the ionic compound must be either in two states, either in aqueous or in molten state, right? So that's why for ionic compounds, remember, it must be either in aqueous state or in a molten state, so symbol AQ or L. So that's why in this case, solid do not process any mobile ions, but liquid can. So that's why I further mark it to D, right? Finally, pH of the aqueous solution. And finally, this is something asking for the characteristics of metallic oxides. Remember in topic 3, we've learned that, right? All the metallic oxides will be having a basic behavior, or simply means alkaline, right? Because when these guys dissolve in water, they tend to form an alkaline solution, just like the case of Na2O, right? So remember, if you put in water, you generate a really strong base, which is going to be NaOH, sodium hydroxide. So obviously, sodium hydroxide is a strong base, so that will give rise to a high pH, right? So that's why obviously the combination goes to D.